All right, here's question number 2 from 2024. And think what type of question it is. So the first question was a table question. Here a particle moves along the x-axis. It talks about velocity. It talks about position. You can see this is a position, velocity, and acceleration question. Again, it's number 2, so this is going to go in your calculator. So let's do that first. So I still have the work from question number 1. I'm going to erase that. I'm just going to type in that equation. So I'm going to type in v at t equals ln t squared subtract 4t plus 5, and then I have subtract 0.2t, and make sure that I typed it in correctly. I see the graph there. I'm not going to put a restriction on this yet until I need to. And now I'm going to start answering it. So in part A it says, is there a time in the interval when the particle is resting, not moving? So to know if it's resting is when the velocity, which is what the graph is, when it's equal to 0. So what is the x-intercept? So I'm going to click on them, and you can see there are 2 moments where it is resting. But it wants the time between 0 and 2. So the second time is after 2. So the one number they're looking for is that first number right there. So I'm going to write that in. All right, so here we are. We're again 2024. Question number 2. So for A, so what are we doing first of all? When the velocity is equal to 0, the particle is resting. And what was that time when the particle was resting? Between 0 and 2, it was 1.25, 1.425. So there's step number 1. So there's your answer between 0 and 2. Then it says, is it moving right or left at that time? So if I plug in 1.425 before that moment, between there. So let's write it in there. So they say from 0 to our answer, which is 1.425, the velocity, is it greater or less than 0? So when I look at the graph, between 0 and that point, you can see the velocity is positive. It's above the axis. So that tells me the direction if the velocity is positive. So since the velocity is positive, the particle is moving to the right. And you wrote down like what you're doing, you're writing down what you're doing, why you're doing it, all of it, and it's perfect. Part B. Part B says find the acceleration. So how do you find acceleration if you know velocity? And the answer is you take the derivative. So we're going to take the derivative and plug in 1.5 and then have an answer. So we're going to go back here, take the derivative at 1.5 and write the answer down. So that's -1. We don't have any units in this question, so we don't have to worry about units. Then the second part, is the speed increasing or decreasing? So we've seen this question a few times. Is the speed increasing or decreasing? We need to know if the signs are the same or different. So the acceleration is -1. Now I need to know just the velocity at 1.5. And I need to know what the answer is and if the signs match or if the signs are different. So just the velocity at 1. Oh, not 1, sorry, at 1.5. That's going to make a difference. So the velocity at 1.5 is -0.076. So what do you notice about the signs is that they are the same. So since the derivative and the velocity at 1.5 share the same sign, that's negative, the particle's speed is increasing. So if the signs are the same, the speed is increasing. If the signs are different, the speed is decreasing. Part C. The position of the particle at time t is at t equals 1. The position is -3. So find the position of the particle at 4. So to find the position of it, let's start with what we know. So the starting value is at -3. Then we integrate. We start with the t value that we're given, the starting one, which is 1. And then we go to what we're looking for, which is 4. And we integrate the velocity. And that will give me the position. So I'm going to come back here. So -3 plus, we're going to integrate from 1 to 4, the velocity, and get our answer. So the answer is -2.802. All right, last part here, part D. Find the total distance traveled by the particle from 1 to 4. So to find the total distance, we integrate from 1 to 4, and it's the absolute value of velocity. And then we type it in, and we have our answer. So again, we're going to integrate from 1 to 4. Absolute value, so I need the keyboard and go absolute value of that velocity. And it's 0.958. That's it. Question number 2 is done. Mr. G Math over and out. On to question number 3.